Gauss's divergence theorem, part 3. Same solid, same vector field. Now what we want to do is evaluate this right side, f dot n dA, and we're going to evaluate it over 6 parts. I started off with the first part. We'll start with the right side. That's this face over here. It turns out y is fixed at 2, x goes from 0 to 2, z goes from 0 to 2. And the unit normal is j. And so f dot n is, you can fill in 2 right here. X and z have to remain as variables, but we're dotted on j, so when we dot it together, you get 4 times 1, which is 4. And then what we want to do is set up a plane integral. You're really integrating over the surface, and then it turns out x and z both go from 0 to 2, y is fixed at 2. And so that gives you 0 to 2, 0 to 2, 4 dx dz. You can do it either order, doesn't matter. Well, that's 4 times 4, which is 16. So I'm going to keep a tally over here. 16. Okay, let's work our way around in this spot right here. We can do the front. Doesn't matter what order we do it. And the front, we're talking about this face right here. X is fixed at 2. And then it turns out y goes from 0 to 2, z goes from 0 to 2. And it turns out n is I. That's this I vector right here. And so we can calculate f dot n is equal, you can plug in 2 right here, gives you 4i plus 2yj plus 2zk, dotted on n, which is I, and you get 4 times 1 plus that times 0 plus that times 0 just gives you 4, and we're going to integrate for the variables of integration are y and z, 0 to 2, 0 to 2, and of course that's 4 times 4 or 16, and so we get 16 for that. And let's see, we did the right side, we did the front. Let's do the left side. And in the left side, it turns out y is equal to 0 there. X varies from 0 to 2, z varies from 0 to 2, y is fixed at 0. And of course we have j on this side, negative j on that side. We're talking about that right there. And so f dot n is equal to, we can put in 0 for y right here, 2xi plus 2 times 0 j plus 2zk, and that's dot negative j. Well, guess what? 0 times negative 1 is 0. And so we're going to integrate 0, and that's equal to dx dz, 0 to 2, 0 to 2, and we're just going to get 0. I'll put my tally there. And let's do the back. We worked our way all the way around. Okay. I hear my kitty coming. She wants to learn about flux. There we go. Say hello. Say bew. Mu, she knows all about the coefficient of friction. She says mu. Okay, the backside. Let's see, on the backside, we're really in the YZ plane. X is fixed at 0. And on the front side, the unit normal vector is I, and the back side is going to be negative I. It goes in the opposite direction. And equals negative I. And F dot N is equal to X is 0, so we're going to put a 0 in here. 0I plus 2YJ plus 2ZK dotted on negative I. Now we get 0 times negative 1 is 0. And so we have double integral 0 to 2, 0 to 2, 0, dy, dz, and that's 0. Okay, we're supposed to get 48, so we're 16 short. I think I know where we can find it. Let's look at the top. Okay, on top, this is like an xy plane integral. Z is fixed at 2. Our unit normal is k, and that's this k vector right here. Points straight up. And so F dot N is equal, you can plug 2 in right here, and we get 2xi plus 2yj plus 4k dotted on k equals 4. And we want to double integrate 4, 0 to 2, 0 to 2. You can do it dx, dy, dy, dx, whatever you want, depending on your favorite order of integration. And that's just going to be 4 times 4, which is 16. Okay, and we have one more surface for completion. I know the answer has to be 0 because this has to add up to 48 because Gauss's divergence theorem is correct. Pretty much anything Gauss said was true. He was a fabulous mathematician. One of the top 3 of all time, they say. Okay, let's do the bottom. Okay, we know that Z equals 0. X and Y go from 0 to 2, and the unit normal vector is negative k. It's pointing in the downward direction. And it's an outward normal, by the way. This is an outward normal, points outward, outside the surface. F dot N is equal to, Z is 0, we're going to put a 0 right here. 2xi plus 2yj plus 0k dotted on negative k. Guess what? That's 0. And so we get double integral 0 dx dy 0 to 2, 0 to 2. That's just 0. So you can add that up to your tally. What does it add up to? Adds up to 48. So, okay, let's make a final statement for completion. Double integral over, double integral, sorry about that. I got 50% too many integral signs. F dot N dA, I guess I should have a vector here. is equal to 16 plus 16 plus 0 plus 0 plus 16 plus 0, which is equal to 48, as promised. You can make this as complex as you want, and the statement will always be true. So that's it for Gauss's divergence theorem, part 3.